Ordering the PCB is way easier and cheaper than you might think. I recommend using JLC PCB because I've used them in the past while paying with my own money. I always got really great results, plus if you're in Europe they will also handle all the customs for you. They also offer to pay me a small commission at no extra cost for you. It would really help me out if you use that link. There are also clickable links in the bill of materials and the assembly manual. All you really need to do is upload the included Gerber file, put in your address and your payment details. There are multiple ways to upload the data on the website, but they all will end you up on the same page. For example, you can click the Upload File button directly on the landing page. You can also click Get Instant Quote and upload the file there. After uploading the file, you will see a preview of how the board will look like. With this, the mandatory part is already done. You could now select Save to Cart and go ahead and order it. I will show you a few optional changes you can make before saving to cart. The default order quantity is 5 PCBs. This also offers the best price per unit. So unless you definitely need more boards, there's no sense in chasing bulk rebates. You can also select different board colors at no extra cost. But this also increases lead time by a few days. The board isn't visible from the outside later on, so that's your call to make. By default, the board is shipped with leaded solder. For a small premium, you can also get solder without lead. ENIC means a gold-plated board, but that's way too expensive for such small quantities. For handling reasons, JLC PCB prints an order number on the boards. At no extra cost you can select to have that order number printed in a specific position. The file already contains the necessary marker. With that, the order number will end up below the Arduino where it won't be seen anyway. You can also have that mark completely removed at a small premium. We can now select Save to Cart and then proceed to the checkout. Make sure to activate the board's checkbox on the left side of the page. You'll also need to enter your address. I don't, since I already have an existing account. Don't worry about the price tag. By default, the expensive DHL Express shipping is selected. We'll change that in the next step. If you live in Europe, I recommend Europacket. With this option, JLC PCB will handle all the customs for you. It's also pretty inexpensive. It's also possible that another option exists for your country that I can't select since I'm from Germany. In any other case, you can select Global Standard Direct Line. It's even cheaper, but they won't handle customs for you. It also takes a bit longer to arrive. You can then proceed to the last step, which is placing your order. You just need to click Submit Order. There's also an option that they review the board before you place the payment. But since the board has proven to be working already multiple times, that just slows down the order. Just click Submit Order and that's it. Before we can flash the software onto the Arduino, we need to install a few external libraries using the library menu on the left side. Make sure the options for type and topic are set to all. You then need to type in the exact name of the library as I show you here. The installation itself is extremely easy. You just need to click the install button. The drop-down button on the left lets you select the version of the library. In this case, the latest one is also the one we need. To select an older version, just click on the drop-down menu and select the appropriate version. Then click Install. Since we need the latest version of this library, I'll update to the newest version again. I quickly show you the other libraries that I used, which I have already installed. Make sure to check the written manual to find out which versions are the latest recommended. For example, as of making this video, I use version 2.5 of one button because the new version 2.6 has grown too large and will exceed the memory of the microcontroller. A newer version is not always better, and all the functionality has been tested with the old version. Now there's one additional library we can't install from the Arduino library manager. This library is called MD-Menu. Although there is a library with the same name in the library manager, I needed to make a few additions to that library specifically for Gatoino. To be more specific, I added the functionality to easily edit hour, minute and second values. To install MD-Menu, we simply need to copy the content of the zip file provided under software inside the package. You can also get the latest version from GitHub. The link is provided in the written manual. It needs to be put into the library subfolder of the directory you selected when you installed the Arduino IDE. The name of the folder doesn't really matter. The most important thing is that you have the same library files as I show here inside the SRC folder. After you copy the files there, we are ready to flash the Arduino. Close the library menu if you still have it open. Just in case you didn't already open the Arduino CatLaser pointer sketch, you can do that now. Simply click the INO file inside the folder. Never mind that I'm showing this on Mac, it works the same on Windows. Before we can compile the sketch, we need to make sure that the appropriate board is selected. We need to select the Arduino Nano from the Arduino AVR boards menu. We also need to select the appropriate port for the Arduino. If you don't know which one, just open the menu once while the Arduino is not connected. Then connect the Arduino and check again. The port that has appeared now is the one that the Arduino uses. It works the same on Mac. Although the naming is a bit different, instead of a COM port, we are looking for a USB serial device. Now there's one additional thing, depending on the Arduino you bought. Cheap Chinese clones often use an older version of the bootloader. This doesn't affect the device at all, but you need to select the appropriate option in the menu. I will show you how to know which one you need to select in a minute. For now I'll select Verify to see if the sketch compiled successfully. After compiling you will get a success message, and you can also see that it's using 98% of the available storage. This is the reason why we need older versions of some libraries. So now we can try to flash the software onto the Arduino. In my case I have selected the wrong bootloader. You can recognize that pretty quickly since the LEDs marked RX and TX need to be flashing pretty quickly. In this case they don't. After patiently waiting for around 2 minutes you get the error message shown here. But you can also speed things up by simply unplugging and plugging the Arduino again. You can then change the processor type and try again. Select the one marked Old Bootloader. Now this time the RX and TX LEDs are flashing properly. The upload takes only around 15 seconds in total. The last flash of the L LED marks the end of the upload and the restart of the device. The Arduino is now ready to work with the Gatoino board. First we install the USB port. The order shown here is optimized to make soldering as easy as possible, so it makes sense to stick to the order I show here. Make sure that the port lies completely flat on the board before starting to solder. Because of the through holes, all parts fit from both sides, so make sure that you only install them on the side where the name is shown. I always start by only soldering one pin and then checking again if everything is still as intended. The port still lies flat, so we can go ahead and solder the other pin. These 2 pins on the side that I soldered first provide the ground connection and also take all the force when putting in the plug. I always check if the solder penetrated all the way through, and if not I'll add a bit more solder. In many cases there is still some flux left, so simply reheating the joint for a bit longer makes the solder flow through. In this case I reheated one joint and the other one needed a bit more solder. When reheating, only do it briefly to not melt the plastic of the parts. After checking if everything is still flush, it was time to solder the actual power pins. It's good practice to clean up the solder tip from time to time to prevent buildup of material. The power switch is the next part to install. It also needs to be flush and perpendicular to the board. As always, I'll solder one pin first. After checking if everything is still fine, I'll solder the other pins and also give that first pin one more heat up. Final visual inspection, and then we can move on to the next component. The next step is soldering the resistors. There are 2 of each and we are soldering all 4 at once. Before insertion, their legs need to be bent 90 degrees pretty close to their bodies. Take note of the resistor values that are printed on the board and don't confuse them. The 150 ohm resistors contain a green ring and the 15K resistors have a red ring. After insertion, bend one leg up and one leg down. That way they don't fall out and they also don't touch each other while soldering. The resistors are necessary to manage the in and out flow of current for the MOSFETs we solder in the next step. Since their position doesn't need to be accurate, you can solder all joints at once. Make sure solder penetrated all the way through. Reheat or apply more solder if necessary. Now the solder went all the way through. Cut the legs after soldering. This is easier when you bend them all up first. I'll cut them facing the camera so you can see what I do. It's way smarter to position the cutter first and then cut them while facing the table. Otherwise those legs fly everywhere. Now on to the aforementioned MOSFETs. Their packaging has one flat side which needs to align with the flat side printed on the board. If you put them in the wrong direction, the servos won't work. Their legs have quite a bit less spacing than all the other components so far, so you have to be extra careful here. Only apply a very tiny amount of solder. Don't worry if you put in too much though, I will show you how to fix that in a minute. If you're already experienced in soldering, feel free to skip the next step. After adding solder to one leg, I reheat that solder and move the MOSFET up a tiny bit so I can inspect for short circuits from both sides. I'll then proceed to solder the leg on the opposite side to not accidentally reheat the first leg. After that, I'll solder the leg in the middle. As you can see, I accidentally caused a short circuit. By cleaning the soldering tip first and then swiping away from the board, I can remove excess solder. This is easiest done by pointing down and using gravity to your advantage. I only do it this way so you can see it on camera. Alternate between cleaning the tip and swiping away the solder. For difficult cases, adding a bit extra flux can help as well. If you have a magnifying glass, now is the time to use it to check if the short circuit is resolved. Adding the second MOSFET works exactly the same. If you have a multimeter, it's a good idea to check for continuity. This is easier if you spread the legs a bit apart. Since we are going to cut them anyway, it doesn't matter. There should be no continuity between the legs of the MOSFET. If everything is fine, we'll cut the legs short. Since you already have seen how that looks, I'm facing the table now to prevent a mess. Next step are the two pin headers for the servos. As always, solder one pin first. Those pin headers don't need to be perfect in order to work though. Still, I'm trying to align them as good as possible. Don't heat them up for too long, otherwise the plastic base will melt quickly. The pin header for the display needs to be aligned a bit more accurately. In order to fit the printed part, it should be at a 90-degree angle, give or take. You already know the drill. Solder one pin first, then align the part and then solder the rest. Next step are the buttons. I'm using the 12mm version here. I'm also doing all at once, but you can do them one by one if you want. Double check if they're flush to the surface, otherwise the controls won't work later. There's not much tolerance in the printed parts, so take your time. Unlike most of the other parts, the buttons won't fall out on their own. They are easiest inserted a bit diagonally. You can also use the printed D-pad in order for the board to stay level like I'm doing here. Again, solder one pin first. Then check if the buttons are still flush, and if so, solder the one diagonally next. If everything is still flush, you can solder all the rest of the pins. Be careful not to touch any of the plastic parts like the power switch with a hot soldering iron. If you're confident, you can skip the second check like I'm doing here and solder everything at once. If you happen to short circuit two pins, you can swipe away the excess material as shown before. I'm also giving every pin a quick reheat to ensure a good connection. Next step is the Arduino. I'm showing how to solder it directly to the board first, then I'll show you how to proceed with the pin headers later. When placing the Arduino, make sure the pins don't stick out too far and the Arduino doesn't touch the resistors beneath. I usually prefer the pin headers for better repairability, but so far even the cheap Chinese Arduino clones have proven reliable. As always, I'll do two diagonal pins first to fix the Arduino in place. Double check if everything fits correctly. Then proceed to solder on the rest of the pins. Make sure to not touch the display pin header with a hot soldering iron. One additional thing to mention is that some Arduinos don't come with the feet soldered, so you have to solder them on yourself first. Any short circuits can be fixed by swiping the soldering iron as I showed before. If the solder doesn't penetrate all the way through, you can apply some flux on the other side below the Arduino. This should help the solder to fill the hole completely. And again, apply some more solder if necessary. When all holes are filled with solder, we are done. And this is how the soldered in Arduino looks. In case you chose to use the optional pin headers, the process is basically the same. Insert them all the way and fix one pin first. The half gear is a very convenient way to keep the board level while soldering. Just put the highest spot below the board and everything will stay level. Once again, the plastic is very heat sensitive, so make sure to only heat up the pin very briefly. The pin header will basically level itself if you press down with your finger and reheat the pin briefly. Make sure to give it enough time to cool down before you release your finger. Do not insert the Arduino all the way, since it takes a lot of force to get it out again. Just barely put it in, this is enough to check the distances. You see the pin header already tried to slip out again after removing the Arduino, so I had to press it in again. Just to be sure, I double check after soldering the opposite pin. If everything still fits fine, it's time to solder the rest of the pins. It's time to solder in the last component. The capacitor keeps the Arduino's power supply stable when the servos draw a lot of current and therefore prevent the Arduino from crashing. You can see I'm struggling to insert the capacitor here. In my case, a little bend at the end of the capacitor kept me from inserting it, so I had to cut it off first. After I finally managed to insert it, I once again bent the legs to prevent it from falling out while soldering. There are really not much surprises here, just standard procedure. Solder it in and then cut the legs short. And that's already all the components you need for the Gatoino. There's one last thing you can do either now or later. In order to attach the laser, we need to add some solder to the connector pad. I'll just apply some solder and that's it. Later I'll briefly reheat that solder to attach the wire. Now in order to see if everything is soldered correctly, we attach the display and do a quick check. You also need to attach a USB power supply and bring the power switch into position close to the USB port. After a brief moment you should see the Gatoino splash screen. In order to enter the menu, you need to press the up button. You can then move left and right inside the menu. Press down again to leave the menu. With that we check that all buttons work. Now onto the assembly. If you follow the previous steps, the OLED is still attached to the board, so we need to remove it first. The display is then attached to the spacer. It has one open side to make room for the pins of the display. Make sure there are no printing artifacts left on the knobs of the spacer. The spacer should fit on the display effortlessly. Remove the display's protective layer before you put it in the front control panel. The display frame has a pretty tight fit. It needs a firm push, but do not use excessive force. In some cases the display's board is a bit too wide. There are always remains on each side from the manufacturing process. This happened to me here, so I scraped off the remains using a utility knife. Make sure to only scrape the edge of the board and nothing else. After that the display should fit in easily. Before adding the board, put in the directional pad as well. Make sure you use the right version depending on if you soldered in 8 or 12 mm buttons. The primary thing you need to align are the display pins with the pin header on the board. With that, the board still has some wiggle room to align with the screw holes. Hold the board in position with your fingers and test the D-pad. If all buttons work, it's time to put in the screws. I use 6 mm M3 screws, but you can also use the 10 mm version if you only have those. In any case, you need 6 of them. You only need to screw them in far enough so that the board doesn't move anymore. Do not screw them in too tight to prevent damaging the board. I screw them in until they almost touch the board, and afterwards I check if the board can still wiggle. As long as the board still moves, I tighten them down just a bit more. Repeat this process until the board doesn't move anymore. Next is gluing on the mirrors. Since the glue only holds the mirrors in place against gravity, it doesn't have to withstand much force. Therefore you also only need a very tiny amount of glue. I already used way too much here. I use super glue here, but you can really just use any type of glue. You just need to make sure that the glue has enough time to cure before you continue. I apply pressure with my finger onto the mirror since that helps the superglue to cure. Be very careful to not glue your fingers onto the mirror. I got a tiny amount of glue on mine, which you can see here. Remove any remaining glue from the sides of the part. Repeat the same process for the large mirror. This time I had more luck with applying only a small amount of glue. In my case, the large mirror also has an adhesive pad on the back. In this case, make sure to remove the protective layer as well. I don't just use the sticky pad because the 3D printed part has an irregular surface. The sticky pad doesn't do a good job of filling in all the gaps, so I'm adding glue as well. Again, for super glue, apply enough pressure with your fingers for the glue to cure. Do not glue your fingers on as I did here. But also don't worry if you got some on the mirror surface, we'll fix that in a second. You can remove any residue using a utility knife. Don't worry too much about scratches, this isn't rocket science and the laser doesn't really care. Just scrape the blade gently over the surface. You don't need to apply much pressure. Just go back and forth until everything is removed. I give them both a final wipe with isopropyl alcohol to make sure they are clean. Next step is adding the servos to the laser cage. For both servos, the cables have to be routed out to the bottom of the part. This is easiest done by just inserting the servo from the bottom of the part. The screws you see here are the two larger ones that come with the servo. Putting the screw on the top of your screwdriver and holding it in place with your fingernail makes for the easiest insertion. An electric screwdriver makes the job a bit easier, but isn't mandatory. The servo you see here is the one for the left and right movement. It is a bit special because one side of the servo is screwed from the front and the other side from the back. The order in which you put them in doesn't really matter. Screw them in tight, but don't overdo it. There isn't much force involved later anyway. Put in the front back servo from the bottom as well. Make sure the cable isn't squished between the body of the servo and the laser cage. The routing of both cables has to look like this. Now it's time to add the gears to the servos. They have a pretty tight fit, so they need to be squished on with a bit of force. It pays off to print them a bit slower for increased precision. If you want, you can print them with a 0.2mm nozzle, but a 0.4 works fine as well. You can also use a utility knife to make the hole a tiny bit bigger if it just won't fit. Hold the gear tight while putting in the screw. If the servo moves a bit, it's not a big deal. But since those servos have end stops, they might break off if you move the gear too far. Since the servo works with a lot of reduction gearing, you might also break off some teeth if you aren't careful here. Before we continue adding the mirrors, we need to center the servos. At this stage it doesn't matter which servo you plug in which connector. Just make sure that the yellow wire is facing the direction of the Arduino. Then plug in the power and move the power switch close to the USB port. You can skip the splash screen by pressing any button as soon as the word Gatoino is complete. Then press up to enter the menu and all the way to the right until you reach Center Servos. If you then press up again to confirm, it will center both servos. Once is totally enough, but you can also do it twice to be sure. If none of them has moved, they might as well already be in center position. But just to make sure there isn't any other issue, like for example with the MOSFETs, it's a good idea to move the gear a little bit and then check again. After you're done, remove the cables and put the electronics aside so we can continue with the mirrors. The first step is to attach the large gear to the small mirror. The side facing away from the print bed is a tiny bit chamfered, so it makes sense to insert the mirror from this side. When fully inserted, the mirror's hex is flush with the surface of the gear. The mirror needs to be positioned at a 45-degree angle. This doesn't need to be perfect, but try to get the closest approximation. This is how that looks from the front. After you align the mirror, put in the gear from behind and screw it tight. If you accidentally move the servo gear in that process, you need to center the servo again. If you have already positioned the mirror and the mirror moved as well, this doesn't matter and you don't need to recenter. Just make sure that the gear teeth always mesh and don't lose contact. Once again, grab the gear firmly while screwing in tight. The holes of the mirror parts are designed to bottom out way before they get stuck, but still you should check if there is some play left. It's always a good idea to do a quarter turn counterclockwise after you're done to make sure everything can move freely. Notice that there is still some play left. This is perfect. We don't want the gears to be completely tight. If your gears ended up stuck, you can use the scaled down version I also provided. Now onto the large mirror. This one takes a bit more attention. Notice there are triangles on both parts which indicate how they need to be put together. Align them with each other before you push the hex in. Again, it should be flush with the gear surface. When connecting the half gear with a servo gear, there's another triangle indicator on the half gear. This needs to be aligned with the servo gear tooth sticking out the farthest. That means the one pointing directly to the screw hole you can see on the right. Once aligned, tighten the screws from both sides just a little bit before you proceed. Before tightening all the way, grab the part firmly to not twist the mirror axis. On the gear side, this is easiest done by just grabbing the gear. This part's hole is also designed to bottom out way before it gets stuck. You can see there's still some play left after tightening. For the other side, you probably need to move the servo a bit to get a firm grip on the part. I once again do a check if there's still some play. If not, I'll turn the screw counterclockwise a tiny bit. After everything is tight, I'll center the servos again to double check the mirror's positions. As you can see, the upper mirror isn't really in a 45-degree position. This is because I had the half gear slip off while assembling. By twisting the frame a little bit, I can align the half gear with the right tooth on the servo gear. Since the servos don't move their complete range of motion, there's no danger of the gear slipping off later in automatic mode. After centering the servos again, everything looks perfect. It's time to add the laser diode. There's a hole on the right side of the laser cage where it needs to be plugged in. The part is designed for the diode to automatically align and stay in place. The only thing you need to do is push it in firmly with a flathead screwdriver and be careful not to damage the wires. It has to be put in deep enough for the wires of the diode not to stick out of the side of the laser cage. This part is crucial. If necessary, give the mirrors one last wipe. We're about to put them in the case where they can't be touched anymore. The main case has a small bridge for the servo cables to be routed through. It makes sure the cables stay away from the moving gears. It also makes for an overall cleaner look from the front. Make sure to not cross the wires when you put them in, so you can identify each servo easily when plugging it into the Arduino. I accidentally crossed them, so I need to straighten them out later on. Since that involves a lot of fiddling, it's easier to just do it right the first time. With the two cables in, we place the servo cage in the frame and then we pull the wires straight. They just need to be guided. Do not use excessive force to pull them straight. This is the part where I needed to uncross the wires until I could continue. If the cables form a loop like you see here, it doesn't really matter. The only goal is to keep them away from the gears. It is often easier to remove the laser cage from the frame in order to pull the wire straight. After that you can plug it in again. With the laser cage in place, do one final check if the wires are straight. After that it is time to install the electronics. We'll also need a soldering iron one last time. Now it is time to connect the servos. Take note of which cable belongs to which servo. This one is the front servo, labeled Servo F on the Arduino. The other one is the side servo, labeled Servo S on the Arduino. The yellow signal wire has to face in the opposite direction of the USB ports. The order in which you plug them in doesn't matter. Just make sure you don't confuse them and switch the connectors. Otherwise the configuration of the laser movement limits will be messed up. Now it's time to solder on the laser diode. We already put some solder on the pads in an earlier step. With that we just need to quickly heat it up and put in the wire. The polarity is important here. Blue is minus and red is plus. It only takes a brief moment for the solder to heat up, but you need to wait a few seconds for it to become solid again. It doesn't need to be pretty, but make sure that the wire is covered with solder and not just lying on top. And that's already it. You can turn off the soldering iron again. Before we screw in the front control panel, we need to put it in place and also make sure that the wires are tucked away neatly in the bottom part of the case. Make sure that the wires are not jammed anywhere. I also tuck in the laser cable here to show you how it should look before putting on the lid. In case it slips out, make sure to double check before putting on the lid. With all cables tucked away like this, there's no danger of them touching the moving gears later on. Next step is screwing the front control panel tight. Since we're screwing directly into plastic and there's no excessive force involved, make sure to not over tighten the screws. It might take you a few extra turns for the screw to initially fit into the hole. After that everything should be smooth sailing. Before I show you how to install the window, I'll talk about an additional upgrade you can do. I used my laser cutter to add a frosting effect to the bottom part. You don't necessarily need a laser cutter though. You can also do it with a piece of sandpaper. The frosted part is about 12 mm or a ½ inch. You can just put on some masking tape and sand down the bottom part. And here's how it looks. It hides away the gap at the bottom through which you would otherwise see the cables. It makes for a bit nicer look in my opinion, but it's totally optional. Now before you put in the window, make sure to remove the protective foil if you still have it on. All edges will be hidden by the case, so don't worry if you have a rough cut from a table saw. You can see my edges are also pretty rough here. Make sure to wipe off any remains from the cutting process. If you use the saw, you can also scrape off the edges with a knife. After that you can slide in the window. Make sure it sits firmly in the slot in the case. It lies only loosely on the electronics front plate. It is held in place by the slots on both sides of the case. Make sure the window is clean. You can't remove any residue on the inside later on. Before we finally put on the lid, we need to add the power switch slider. It should slide on the switch very easily. If not, try printing one with a slower printing speed. Make sure the laser cage is perpendicular to the bottom. Everything should come together easily. With a less precise printer you might need a bit more force than I do here. Now it's just a matter of putting in the remaining screws. It's also a good idea to check if the power switch moves freely before you put in all the screws. It's time for the final check. Plug in the power and turn on the power switch. You should see the splash screen after a few seconds. You can wait until it disappears on its own or skip it with any button. Pressing the down button starts and stops the laser. With that you can check if the laser moves in all directions. Don't worry if it stays in place for a few seconds, since staying in place is part of the randomized game loop. And that's it. Congratulations on building your very own Gatoino. I hope you and your cat will have a lot of fun with it.